All right, so guys, next up, example number 4. So we've got the elementary row operations up there again. We just want you to see, as a reminder, I guess, what it is that we're going to be attempting to pull off. All right, so this one, again, hopefully isn't too horrible, but we are going to take, we're taking a step to the next level for sure. Okay, so our row operations, the options that we have, we could interchange row, you could multiply by a non-zero constant, you could add a multiple of row to another row. So this time, do we all agree that to go from the 2x3 matrix to the new 2x3 matrix, row 1 stayed the same this time, doesn't it? So we're targeting row 2. All right, now could we change from, or look at this from, all right, I'm at -4, I need to get to 5. How am I going from -4 to +5? We could look at that, but that's going to make that, like, I feel like in some ways like we're going out of our way to make it harder on ourselves, okay? The hint was before, not to do that, the hint was before to try to set it up to where whatever I'm coming from to get to 0. That's going to be the easiest one. Now the reason why that's going to be easier, think back to the previous, to where we said, I forgot what it was now, we were going from 3 to 1, we had 2 options. We were either multiplying by a third or we were subtracting 2. How do I go from 3 to a 0? Multiplication's off the table, isn't it? Because we were very clear, hopefully, when we said that that second rule was that I could multiply, but it had to be by a non-zero constant. The only way I'm going to multiply 3 and get 0 is multiply by 0. That's off limits. That's not possible. So, what is now our only way to go from 3 to 0? We've got to subtract 3. Since we don't have subtraction in there, it has to be addition, we just have to switch it in our brain to say we have to add -3. So, guys, I really want to stress it this way. I feel like I could have done a better job in second period by again, just being more adamant about this. But guys, the third option of elementary row operation, the one that we're about to use right here, it's just the elimination method. If this were a system, 3x minus y equals -4, -4x plus 3y equals 7. If it looked like that, and I said, all right, go in and eliminate the y's now, would you know how to do it? Of course you would. I have no doubt in my mind that everybody in here, oh, eliminate the y's? Perfect. How would you do it? Just out of curiosity. In fact, I'm going to write it up here, because I feel like some people left here confused and they didn't need to. If this was my system, and we said, all right, we're going to target the y's, let's get rid of them. What are we doing? What are you going to tell me to do? We're going to multiply the top equation through by 3, and then what? So that's going to be 9x minus 3y equals -12. Second equation, what do I have to multiply it by? Nothing. It's going to just say it, -4x plus 3y equals 7. And then we're going to add those together, and we're going to eliminate the y's. It's the exact same thing that we're trying to do here. We're trying to go from 3 to 0 by adding the opposite. We're trying to eliminate that 3. So, using what we have, how am I going to eliminate it? I can't just come in here and say, yeah, we're going to take row 2, and I'm just going to subtract everything by 3. Not only is that not an elementary row operation, but that wouldn't do it for us. -4 minus 3 is -7, and that already is not going to work. So what we have to do is we have to use my other row. In this case, I can get away with saying my other row. There's only one. But if we had like 5 rows here, I would have to use one of my other rows, and I'd have to look within that column, do I have a value that I could multiply to create an opposite that I could add? Does that make sense? So we've already done the work over here. If we're to write this up in terms of row operations, what did we do to row 1? So we did 3 times row 1, and then what did I add it to? Didn't we add that to row 2? Isn't that what we just did? All right, so in matrix world over here, what's that going to look like? If I took row 1, 3 times row 1, so 3 times 3, -1, -4, if I multiply that out, what's that going to look like? Distribute, we get 9, -3, -12. We said that we're going to add that to row 2. Add that to row 2. Row 2 was -4, 3, 7. When I add these, now what do I get? 9 plus plus negative 4 is 5. Negative 3 plus 3 is 0. Negative 12 plus 7 is negative 5. We did it, didn't we? We got there. Okay? So, again, this is the hard one to see. It seems like we're taking just like we're pole vaulting to the next step. It's that far up or something like that. It's not that huge of a jump, really. We're doing the elimination method. Okay? You've been doing that. You could do this in your sleep if this were written out as a system. If it helps you, write it out as a system for all I care for right now. But I think that we can get away with not having to do that or not needing to do that. But it's just like a system. All that we're doing is we're going to use within the same column, because right now that's the y column, we have to cancel the 3y. We have to eliminate it. I'm going to have to use my other row in order to create an opposite. You think we can do that? I think we can. So our answer here, again, the row operation 3R1 plus R2. All right, guys, how do we feel on this one? Now, part of it, I understand, guys, what time is it? 3:06 on a Friday. It's been a long week. I get it. I understand all that. But give me 14 more minutes. Okay, we got this. 14 more minutes, and I'll leave you alone until Monday. Kind of. You'll have homework, but get the idea. All right, so the goal that we have in mind here, again, if we're trying to put this into row echelon form, as we said, the goal is to get positive ones on the diagonal. Try to get zeros underneath. So these are your row operations. A few of the recommended steps here. If you are in a position to where you write up you go from your system to your augmented matrix, and you notice, I have zeros and ones exactly where I would want them, but it's in the wrong row. Remember, you can just flip the rows. If your third row has that leading coefficient of positive 1, and you're thinking, gosh, that would be nice if that were in row 1, interchange them. Again, that'd be a great place to start. Okay? Remember, we're trying to get ones on that diagonal, zeros underneath. Typically, just kind of as a reminder, or not really a reminder, but we haven't done this before. Remember that we're trying to get this. Let's do this, or whatever these numbers are. So as we're working, this is the order. You want to do this number first. Row 1, column 1. That's the first thing you want to do. Start here. Once we have that, then we just work up the columns. We're going to go here, we're going to go here, we're going to go there. Okay? So again, always do the top left initially. That's your first thing. And then just stay to the left, work up the column, work up the next column, work up the next column. Okay? The reason for that, technically, it's not mandatory that you do it this way, but I've done enough of these before, and I've worked with enough students doing these before, that the biggest frustration is when you go to work and you figure out, okay, I got a 1 here and I got a 0 here. Perfect. I had to work really hard to get there. And then you do the next operation, and then what was a 0 and what was a 1 becomes something else. Like you undid what you just did. That's frustrating. We want to stay away from that. And if you go in this order, the proper order, you won't undo what you've done. If that makes any sense, which probably makes no sense right now. But again, as we do more and more of these, you're going to notice that we always approach these in the same fashion. All right, so let's go ahead and take a look at this first one. This is the full gamut here, so to speak. Now, I'm asking you at the beginning of the day today. I asked you to not allow yourself to get frustrated. The other thing I'm going to ask you to do here is turn off the part of your brain that's saying, this is a joke, right? I could solve this like a system in 30 seconds. I know, I get it, but we're not working in systems right now. We're working in matrices. So again, we've got to make sure. Now, if you wanted to solve it like a system to check your work later on, great, that's fine. But we have to show the work for a matrix. All right, so first step is going to be to rewrite as an augmented matrix. All right, so 2, 6, 16 will be my first row. 2, 3, 7 is going to be my second. All right. Now, remember what the goal is, the target here. I'm trying to get ones on the diagonal, 0 underneath. I'm actually going to push us to go one step further. We're going to get reduced row echelon form. This is only one more step. And then we can have our answers directly. But that's what we're trying to obtain. All right. Now, if you're thinking, could we get this into a 0 to start? Yeah, we could. But just for the principle, we're going to start in that top left corner. All right, I have a 2. What do I want that to become? We need that to become a 1. So, a lot of different ways that we could do this. Please don't feel obligated. I don't want to feel like I'm micromanaging to the extent that I'm telling you exactly how to do this, exactly how to think, exactly what to write first, second. I don't want to feel that way. I don't want you to feel that way either. But I'm just going to report what has worked well for me. For me, I like to start with the rows that we're not touching, because the worst part about dealing with matrices is that you're going to have to copy the matrix multiple times. And if I accidentally write this as 2, 3, 7, instead I accidentally write it as 2, 3, 9, the whole thing's going to get screwed up. Okay? Or if I accidentally write that as 2, 3, negative 7, I mean, those are the types of mistakes that we struggle with. So I always like to start with, all right, what are we not touching? Second row is going to stay the same. Got it. All right, so how do I turn a 2 into a 1? That's now the big question. We have 2 options. Technically, we could subtract 1, or what could we do? So multiply by 1/2. Good. So I think that's our better option here. What is 1/2 times row 1? Okay, now why do I say that's our better option? Because if I wanted to turn this into a situation where I'm adding -1, I would have to multiply the entire second equation through by -1/2 and then add it. Yeah, we're overhandling it at that point. All right? So if you needed to see this off to the side, 1/2 times row 1. Remember, we have 1/2 times row 1 is 2, 6, 16. And it's just the distributive property. What's 1/2 times 2? 1. What's 1/2 times 6? 3. And what's 1/2 times 16? 8. All right. 1 down, 3 to go. How do we feel about that first step? We got it? No problems? What were they whining about? This is easy, right? Are we there yet? Still working on it. All right. Yeah, we're working our way up. All right. So what's my next target? Up that column. So we want to turn this 2 into, I heard it out there, 2 turns into a 0. Good. All right. Could I multiply just the entire row through by 0? Nope, that's not an option. So I have to figure out how to add -1 to the positive 2. Okay. We know what we're targeting. Row 2, column 1, which tells me that row 1 is going to stay the same for now. All right, what are we thinking? How could I use my other row within that column to have a -1 plus 2? Because right now I have a positive 1 as the other option. So what are we thinking here? Are we thinking here? Say that again. -2? Elaborate on that. I think you're on the right track. Oh, okay. So, unfortunately, like what you're saying is that we could, how do I want to say this? If we currently have a positive 1 here, I need to turn that into a -2, don't I? I think I said -1 earlier, I'm sorry. How do I turn this positive 1 into a -2? Because once I have to do that before I add it to the second row. So what are we thinking? So -2 times row 1 plus row 2. Is that what and Abby, I think that's what you were saying, right? For the most part? No? Okay. We'll pretend that's exactly what you're saying. Yep, perfect. Nailed it. All right. So if we're looking at -2 times row 1. Okay, row 1 is 1, 3, 8. So -2 times row 1, when I distribute that through, that's going to be -2, -6, -16. But we claim that we're going to add that to row 2. So row 2, here is 2, 3, 7. This is what we're going to add together. When we do that, what's -2 plus 2, please? 0. That was the whole point. We wanted to get a 0 right there. But the rest of this now, what's -6 plus 3? -3. What's -16 plus 7? 9. So my new row 2 looks like that. 2 down, 2 to go. All right. What's my next target? -3. We're in the second column now, working our way up. So we are targeting row 2, which means row 1 again is going to stay the exact same. So I'm going to start there, 1, 3, 8. All right. I have negative